So welcome everyone to this video, and since I am positive that you just can't get enough examples of probability questions, I have another one. This one is different from previous examples because of how the information is given, and this type of table where you have let's say people or some object, let's make it really general, some object that is classified in two ways. And in this table, the classification is based on employment and gender, right? And the numbers represent the civilian labor force of 16 to 20-year-olds, and this data is in millions, right? So whenever this data was captured, for instance, this 1.4 here means that at that time there were 1.4 million females in that age group who were unemployed, right? So what are we going to do with this, right? This is our sample space, and what the experiment here is, we're going to randomly choose one person out of this huge population, right, or sample space, and then we want to figure out what is the probability that that individual will be in one of these categories, or maybe a combination of them, right? So before we get to the three questions that are listed there, let's define some sets. That way we can use our set notation, even though this is, again, like a story problem. So we can still do it abstractly. So what I will do, let's use E for employed and U for unemployed, M for male, and F for female, right? And then we have some questions. So let's look at the first question. It says, what is the probability that a randomly selected 16 to 24-year-old individual from the civilian force is employed? Well, employed, that means the person could be male or female, but with a total of 21.5 million people in this workforce that are employed out of a total of 24.5. So what I'm going to do with this example is use the N notation, meaning number of elements of, to show you how this will work. So for instance, this question is asking, what is the probability that event E will occur after this random selection? Well, by definition, in the classical method of probability, this would be the number of elements in this set divided by the number of elements in the sample space. The number of elements, excuse me, in the employed set is 21.5. So 21.5. And then the number of elements in our sample space here is the total, right? I like to call this the total, right? It's the total of the totals. But it's 24.5. I don't need to, express it as an actual million, because since I'm taking a quotient, the million will cancel out. So I really just have to take the 21.5 divided by 24.5, and then I'll round this to 3 decimal places, or 4 decimal. I like 4 decimal places. So 0.8776. So there's roughly, if you were to put this as a percentage, then roughly 87.76% of this labor force, well, I'm sorry, 87.76% is the likelihood that this individual will be employed. So, not quite 90%, but still a good percentage. All right. Now let's look at B. So B, it says, what is the probability that a randomly selected 16 to 24-year-old individual from this civilian force is male? So, right, we're asked to find the probability of being in event M. Well, again, in the classical sense of probability, it's the number of elements in M divided by the number of elements, again, in S, right? And in that case, we know it's going to be our 24.5. Let's see if we can figure out what the numerator is. Well, the male category is represented in this column, right? So of all the males, this many are employed, this many are unemployed, for a total of 12.8 million males. So the number of elements in that set is 12.8, right? Again, we can ignore the million since we're doing a quotient. And then, so if we divide those two, again, I'll round this to 4 decimal places, so 0.5224, right? So as a percentage, it's 52.24%, right? So a lot less likely that this randomly selected person is going to be a male. In fact, it's almost 50%. So there's a 50-50 chance that this person is a male or not, right? Or is a male. Okay, so finally, let's look at what C is asking. So C is asking, what is the probability that, again, one of these this individual is employed or male? So the probability of employed, so that's E, or, now, or, we know that verbal, connector or converts over to our union. So it's a probability of E union M. And this requires our general addition rule for 2 events. So this is the probability of E plus the probability of M minus the probability of the intersection of E and M. All right. Well, look, we already have the probability of E. So I'm just going to write this fraction down. So it's the 21.5 over 24.5 plus, and then we have the probability of M. It's the 12.8 over the 24.5, and then minus, what we haven't found yet is the probability of the intersection. But the intersection of E and M would be those in this category. So right here, this is the number of elements in E intersect M, right? So then that number, again, divided by our total is the probability that the individual is going to be employed and is a male, right? So falls into both categories. So let's go ahead and write that. So we have the 11.2 over the same 24.5, right? And so when you compute this, you're going to get a pretty high percentage. What's that? 0.94 and 29. So, almost 95%, or I guess really just over 94%. So 94.29%. Right? So there's a very high chance, not a certainty, but there's a high likelihood that this single individual that we randomly select is going to be either a male, right here, or unemployed, or both, right? So essentially, In fact, let me kind of highlight, in fact, yeah, let me go ahead. Let's take this off. And what I'm now going to highlight is all the elements in this set, or the number of elements in this set. So employed or male, right? So here is male, and then here is now employed. So if we add these, another way we could have done this problem would be to add the 11.2, the 1.6, and the 10.3, and again divide that by the 24.5. So I encourage you to try it that way and see that you end up with the same probability. And again, it just shows you that yes, you can resort to the formulas like we've done here, and also you can look at what's given. That the information in the table it's all there. We just have to know how to read it, right? It's just like reading the graph of a function, etc. It's just different data, but we want to develop the ability to interpret it in many different ways, right? So just another example to give you a little more variety in terms of what types of questions you could be asked, right? See you later.